This is my reassessment for Standard 8, which is Chapter 9. In this problem, we have a system consisting of 3 particles. Each particle has a different mass and a different velocity. Here, we are trying to figure out what the total momentum of the system is, what the velocity of the center of mass of the system is, what the total kinetic energy of the system is, and what the translational kinetic energy of the system is. First, I decided to start off with calculating the total mass of the system, which is M1 plus M2 plus M3. And here it's 4 kilograms plus 8 kilograms plus 6 kilograms, and that's 18 kilograms. Then I decided to go ahead and find the magnitude of all the velocity vectors. And for V1, we have 22.6 meters per second. For V2, we have 15.4 meters per second. And for V3, we have 50.7 meters per second. So to start A, the question is, what is the total momentum of the system? And we know that momentum is equal to mass times velocity. Well, here for the total momentum, we'll have the mass times the velocity of each of the particles. So it's m1 v1 plus m2 v2 plus m3 v3. And so we're going to take the mass and times it by the magnitude of the velocity vectors that we have just found. And that gives us a total of 517.8 kilograms meters per second. And that's the total momentum of the system. B is what is the velocity of the center of mass. And that is equal to m1 v1 plus m2 v2 plus m3 v3 over m1 plus m2 plus m3. So we've already figured out what the top portion of the fraction is in part A, and that's 517.8 kilograms meters per second, and it's divided by the total mass of the system, which we have already also figured out to be 18 kilograms. And that equals to 28.8 meters per second, and that's the velocity of the center of mass of our system. C is what is the total kinetic energy of the system, and to figure that out, we have the kinetic energy total is equal to the translational kinetic energy and the relational kinetic energy. We know that kinetic energy is equal to 1/2 mv squared, and the translational is simply 1/2 m times v of the center of mass squared. And this is also part D, which is what is the translational kinetic energy of the system. And that is equal to 1/2 18 kilograms times 28.8 meters per second squared, which we had just figured out in part B. And that is equal to 7,464.96 joules. And that's the total translational kinetic energy. Now the kinetic energy relative to the center of mass is equal to 1/2 times m1 v1 squared plus m2 v2 squared plus m3 v3 squared. And all the velocities are relative to the center of mass. And to find that, we take the velocity of the particle minus the velocity of the center of mass. So we have 1/2 times 4 kilograms times 22.6 minus 28.8 squared plus 8 kilograms times 15.4 minus 28.8 meters per second squared plus 6 kilograms times 50.7 minus 28.8 meters per second squared. And that gives us 2,233.95 joules. So we plug both of those numbers back in for the total kinetic energy. And that is 7,464.96 joules plus 2,233.95 joules. And that gives us our total kinetic energy of 9,698.91 joules.